Okay, here we're going to take a look at more about conic sections. And first, I want to play you this little video here that shows you about conic sections and why they're called that. First, you'll notice that there is a double set of cones, hence the name conic. And you'll notice there's a blue line or blue plane that's cutting through them. Well, right now, you can see this red line is one type of conic section. And as we move along this, we have that same thing. It's just changing size and direction and whatnot. And at some point, that blue plane no longer touches this bottom cone. And instead, we get this parabola shape. Now, as we keep moving, that parabola changes size and direction, and you'll notice it's starting to close up. Now, remember that this cone is actually supposed to be infinite, so it keeps going in every direction, all different directions. So right now it's a parabola, but as soon as it starts twisting back in on itself here, that would be an ellipse. Okay, and that's the third type of conic section, is an ellipse. And then when you get the plane going exactly parallel to the top of the cone, or what would be the top of the cone, you get a circle. And as it continues rotating, we have an ellipse. Then it pops and becomes a parabola again. And as it starts to intersect the other part of the cone, we're back to a hyperbola. All right. So let's watch that all in fun-filled 3 dimensions one more time. There are our conic sections. Ta-da! Now let's switch off that and take a look at this this formula sheet. I think if you look online, you'll find in Moodle that I've got this all listed out for you as well. You could just download it. But the circle and the ellipse, they kind of go together here because they're very much related to each other. You'll notice as you take a look at the equations, they both have a plus in the middle of them, which is important. The only real difference between them is that the circle has the exact same numbers here and here, whereas an ellipse has two different numbers. All right, but they both equal 1. And you'll notice that the letter H is always paired up with the X, and the letter K is always paired up with the Y. You'll see that all the way through this whole page. They always go together. And what we get is that these HK gives us our center. All right. The second type of conic section that we saw, the circle and ellipse, I really consider essentially the same type. The second type was a parabola. And there are two different types of parabolas. This one, the one that starts with y equals x squared, would be a vertical parabola, up and down. The other one, where it's x equals something y squared, would be a horizontal parabola. And of course, all these letters mean something. Our vertex is still at h comma k. You'll notice the h is out here, paired up with the x, or in here paired up with the x, and the k is paired up with the y, k and y, or k and y. So the vertex is always at h comma k, and we haven't talked about what this 4p would mean out here. In our adventures with parabolas, we haven't done that yet, but we will come back to that, so don't worry about that. And here is what separates the hyperbola from circles and ellipses. This is a minus sign in here. Anytime you see a subtraction sign between these two, you're looking at a hyperbola. Now, a couple of key features. You'll notice that the a squared is first for both of these. The only thing that's changed is where the x minus h is. Here it's out in front of the subtraction sign. Here it's after the subtraction sign. Doesn't make any difference to me which one's which. It just depends on, all it's going to do is affect the direction that the hyperbola is traveling in. And we'll come back and talk about that a little bit more. Okay, so moving on here, as you have seen from the previous lesson about completing the square, our goal is always going to be to get it into this standard form if we've got it in general form. Or if it's already in standard form, then interpreting what kind of conic section we're going to get. So one of the assignments that you're going to be working on is the assignment, what am I? And part of that assignment is to look at an equation and make some decisions about what kind of a conic section it is. So I'm going to take a look first at number 1, and I see that it's got a double squared, two things squared. I also key in right here on the fact that this is a subtraction sign, which I remember from looking back up here. The only one that had a subtraction sign in the middle was a hyperbola. So this thing is clearly going to be a hyperbola, which, in case you don't remember, is looks like kind of two sort of U-shaped things together. They're not parabolas, but that's kind of what they look like. And we'll talk more about what shape it is, because it's either this or it's going to go sideways like so. Not sure just yet which one, but we'll figure it out. The center of this thing is going to be at h comma k. I don't really worry about the letters all that much. I look back here at the numbers. So I see a +3 with the x, and I think opposite because it's inside the parentheses. And it's inside the parentheses here with the y, -4, so I'm thinking +4. So the center is at -3, +4, and it's either opening up and down or it's opening left and right. And again, we'll come back to which one it is a little bit later. All right, for number 2, here's my equation. I see the plus sign in the middle. I remember that the plus sign is either a circle or it's an ellipse. It's one of those two. So I'm going to just jump back up and take a look at what was up here. Okay, they both had a plus sign, so that's fine. The only difference between a circle and an ellipse was that these numbers are the same here and here. So what do I see? Same number. So it's a circle, and the center of the circle is at, I'm going to pause for a second here. You see if you can tell me what these two numbers are. What do you think they're going to be? Tick, 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 tick. All right, that's enough. Should be +3 and +5. I put the +3 with the x because it's x minus 3. +5 with the y because it's y minus 5. Incidentally, I could move that 16, multiply everything by 16, move it to the other side, and I could tell you that the radius was equal to 4. Woohoo! So I even know what that thing looks like. All right, let's move on to number 3. Here's my equation. Take a look at it. What do you think it is? I see the plus sign in the middle, so it's either a circle or it's an ellipse. And because these numbers are different, I know that it's going to be an ellipse. And the center is going to be at +2, -7. Number 4. On this one, I see it fits the description of a parabola. It's definitely not two squares, which is what the other ones have. So it's some kind of parabola. Now, I always think about my favorite parabola in the world, y = x², which I know goes up and down. This clearly is not an x². This has a y². So since this is a y² problem, then I know that this parabola opens left or right. Either left or right. I'm not sure which one yet. It's not both of them, but it's one of them. But I also know that the vertex, or what might be called the center of the parabola in this case, is going to be +3, +2. See, this +3 at the end shifts it to the right 3 units, and the y minus 2 would shift it up or down, in this case up 2 units because it's inside the parentheses. So the vertex is at 3, 2. For number 5 here, this is in that long factored out form, so I'm going to have to complete the square real quick. And since I'm doing this after school and I want to go home, I'm going to do it kind of fast. So you're just going to have to follow along. If you need to see it slowed down, you watch the other video. Let's see, so I need to add 9 here, which was really a 36, so I'm going to add 36 over here. And in here, I'm going to add a 1, that's half of 2 squared, which is really a -9, so I'm going to subtract 9 over here. So my completed square is going to look like this. And over here I got 36. I need a little more space. I'm going to divide everything by 36. I said I need a little more space. Divide by 36 all the way across, and I get x minus 3 squared over 9 minus y plus 1 squared over 4 equals 1. Well, what is this thing? I see the subtraction sign in between. That tells me that this baby is a hyperbola, and that the center is at, oops, it's at 3, comma, -1. For number 6,